A few years ago, most people believed that only Tesla and BYD were shaping the future of electric vehicles. But now, the conversation may be shifting. This time, the spotlight is not on a startup. It's on a company that has spent decades building its reputation in luxury, performance, and engineering: Mercedes. And the technology creating all the buzz is YASA's Axial Flux motor. For a long time, the EV industry focused mainly on bigger batteries and longer driving range. But today, the competition is evolving. The discussion is no longer just about how far an electric car can travel on a single charge. Now, people are also paying attention to how lightweight a car can be, how much power it can generate, and how efficiently that power can fit into a smaller package. In the middle of this changing landscape, Mercedes has quietly made a move that is now attracting global attention. Unlike Tesla or BYD, Mercedes has taken a different path. Many experts believe YASA's axial flux motor technology could challenge the traditional design of electric motors that the industry has relied on for years. The idea behind it is simple but powerful: less space, more power, better efficiency, and a completely different engineering approach. This has sparked an important question. Could the future EV race be driven not just by battery technology, but by motor innovation as well? So what exactly has Mercedes been working on behind the scenes for so long? Is this simply a new type of motor, or could it become a breakthrough that changes the direction of electric vehicles for years to come? And if this technology delivers on its promises, how will companies like Tesla, BYD, and others respond? Before we continue, don't forget to subscribe to the channel so you never miss videos like this. A few years ago, the EV market seemed much simpler. Most people believed the company with the biggest battery and the longest range would dominate the future. As a result, almost the entire EV conversation revolved around batteries. Some brands focused on offering 500 kilometers of range. Others pushed towards 700 kilometers. Some highlighted ultra-fast charging, while others tried to make larger batteries more affordable. Over time, the EV battle started looking like nothing more than a battery competition. And honestly, there was good reason for that. Tesla proved to the world that electric cars could be fast, intelligent, and capable of long-distance travel. At the same time, BYD strengthened its position through advanced battery technology and large-scale manufacturing. Toyota continued investing in hybrid systems, while Hyundai rapidly expanded its EV lineup with new platforms and fresh designs. Every company was trying to show that its battery technology was better and its range was longer. But while the industry focused on batteries, Mercedes may have been thinking differently. Without making loud announcements or bold claims every month, the company was quietly focusing on another critical component: the motor. Because while batteries store the energy, the motor is what actually delivers that power to the road. When people hear the name Mercedes, they usually think of luxury, premium interiors, comfort, and performance. But very few know the story behind the technology creating headlines today. YASA did not start as part of a major automotive giant. It began as a small technology company, which makes this story even more fascinating. YASA approached electric motors with a completely different mindset. At the time, EV development was already progressing rapidly, but one problem kept coming up repeatedly. If manufacturers wanted more power, the motor became larger and heavier. But if they kept the motor compact, performance suffered. For automakers, this became a major challenge. Inside a car, space is limited. Companies need room for batteries, motors, cooling systems, and passenger comfort, all while keeping the vehicle lightweight and efficient. YASA decided to tackle this exact problem with one simple question: could a motor remain compact while still producing massive power? Could higher performance come from lower weight? That question led the company toward a completely different engineering direction: the axial flux motor. The term may sound technical, but most electric vehicles today use a different type of motor design. YASA believed that by redesigning the way magnetic flow and power movement worked inside the motor, it could create something smaller, lighter, and significantly more powerful. The biggest advantage of this design is its higher power density in a much smaller space. In simple terms, it can deliver more performance without dramatically increasing the size of the motor. And gradually, this technology started attracting attention. In the beginning, YASA was not a globally recognized name, but within engineering circles, people had started noticing it. For high-performance applications especially, this type of motor looked extremely promising. But the biggest question is this: what exactly did Mercedes see in YASA? A company like Mercedes does not invest in technology simply because it becomes popular or trendy. Their decisions are usually based on long-term vision and future planning. At that time, the EV industry was evolving rapidly. Tesla was moving aggressively, Chinese automakers were expanding fast, and the entire conversation was centered around batteries, charging speed, and software. Mercedes may have realized that if it wanted to remain a leader in the premium EV segment for the next decade, battery technology alone would not be enough. They needed something that could make the driving experience truly different. That is when Mercedes decided to bring YASA into its ecosystem. From the outside, it looked like a normal acquisition. But in reality, it was much more than simply buying a company. Mercedes was investing in future technology. The goal was not just to build better electric cars for today. Mercedes wanted to prepare its high-performance EVs for the next 10 to 15 years. And the strategy behind this move was much bigger than most people realized. If the motor becomes smaller and more compact, the overall weight of the vehicle can be reduced. If the motor takes up less space, designers gain more flexibility to rethink the entire vehicle layout. If efficiency improves, the same battery can deliver better overall performance. And if the motor can produce more power, it creates a completely new identity for premium performance EVs. That may be exactly why the name YASA suddenly became part of the global EV conversation. Now, to truly understand why there is so much excitement around YASA, we first need to understand the difference between the motors used in most electric cars today and the axial flux motor technology YASA is developing. From the outside, both may simply look like electric motors. Both run on electricity. Both send power to the wheels. But internally, the way they operate is very different. Most electric vehicles today use something called a radial flux motor. The name may sound complicated, but the idea is actually simple. Imagine a cylinder-shaped structure where one part spins in the center while the outer section creates magnetic force to rotate it. In this setup, the magnetic force moves from the inside outward, which is why it is called radial. This design has been used for years because it is reliable, easier to manufacture at large scale, and well understood by automakers. Now, on the other side is the axial flux motor, the technology YASA has focused on. Here, the design philosophy changes completely. Instead of magnetic force moving outward from the center, the force moves from front to back. A simple way to imagine it is this. If a radial motor looks like a thick drum, an axial flux motor looks more like a thin disc or plate. Think of it like comparing two different fans. One is a large, thick table fan, while the other is a wide but slim ceiling fan. Both move air, but their structure and operating style are very different. The same idea applies here. Both motors perform the same task, moving the car. But the way they generate power is different. The main purpose of any electric motor is to convert electricity from the battery into rotational force. But the method used to create that force changes everything. In radial motors, the magnetic force spreads outward. In axial flux motors, the force works front to back. Because of this design difference, engineers believe Axial motors can achieve a more compact layout and potentially deliver power in a more efficient way. And this is where size becomes an important topic. One of the biggest reasons people became interested in axial flux motors is their compact design. Traditional motors can sometimes require more space, while axial flux technology aims to reduce size without sacrificing performance. That does not automatically mean a smaller motor will outperform every traditional motor in every situation, but the goal is to achieve higher performance within a smaller and lighter package. And that matters a lot in electric vehicles. Inside an EV, every bit of space is valuable. The battery pack sits underneath the car. There are cooling systems, suspension components, cabin requirements, and electronic systems that all need room. If the motor can become more compact, manufacturers can either free up extra space for other components or reduce the overall weight of the vehicle. And weight itself is another major reason why this technology is creating so much excitement. In electric vehicles, every kilogram matters. More weight usually means higher energy consumption. So if one major component becomes lighter, it can improve the efficiency of the entire vehicle. That is why technologies like this are gaining attention, especially in the high-performance and luxury EV market. And then comes efficiency, a topic many people often misunderstand. Efficiency is not only about increasing driving range, it's also about how much energy the system wastes and how much of that energy actually reaches the wheels. If a motor can use energy more effectively, the same battery can deliver a smoother, stronger, and more efficient driving experience. But that does not mean traditional motors have suddenly become outdated. Radial flux motors are still used in most electric vehicles around the world, and they have proven to be highly reliable and successful for large-scale production. Axial flux technology is still relatively new, and scaling it for mass production is not considered easy. Now, the big question is this: how can such a small motor produce so much power? Normally, we associate bigger size with more power. Bigger engines usually mean higher output. But in the electric world, things work a little differently. Here, design and energy management matter just as much as physical size, and that is exactly why technologies like YASA are attracting so much attention. To understand this, we first need to talk about magnetic fields in simple terms. The entire operation of an electric motor depends on magnetic force. The battery sends electricity into the system. That electricity creates a magnetic field, and the magnetic field generates the rotating motion inside the motor. That rotating force is what eventually moves the wheels. In simple words, the actual force that pushes the car forward is created through magnetic interaction happening inside the motor. And this is where motor design becomes extremely important. If a motor is engineered in a way that allows magnetic force to work more efficiently, then strong performance can be achieved even within a smaller package. That is exactly where axial flux technology enters the conversation. The goal is not to create extra power magically, but to use the available energy in a smarter and more effective way. Now let's talk about torque. Torque is the instant pulling force you feel when you press the accelerator and the car immediately surges forward. Electric vehicles are already famous for delivering instant torque. But if the motor design allows power to be delivered more quickly and efficiently, the vehicle can feel even more responsive and dynamic. That is why motor technology becomes especially important in performance-focused cars. Now, another important question comes up. If this technology is so promising, why did Mercedes stay quiet about it for so long? Mercedes has always been the kind of company that prefers to reveal technology only when it is fully developed and ready. In the premium automotive segment, being innovative is not enough. The technology also needs to be reliable, and technology like this is not developed overnight. Behind it are years of research, testing, engineering, and refinement. First comes the concept, then prototypes, then durability testing, and finally, preparation for production. From the outside, it may look like a sudden announcement, but internally, the development usually began many years earlier. Another major reason could be Mercedes' premium strategy. Mercedes does not simply sell electric cars, it sells a driving experience. And if the company wants its future performance EVs to truly stand out, it needs something beyond just larger batteries and longer range. Future platform planning is also believed to be a major factor behind this move. Automakers often design the architecture of future vehicles many years before customers ever see them. If Mercedes is developing the next generation of EV platforms, motor technology must be planned very early in the process. And of course, competition is another big reason. Tesla continues pushing innovation aggressively, while Chinese automakers are expanding at an incredible pace. In this environment, Mercedes does not want to simply follow the market. The company wants to create its own direction. That is why many people believe this move was never sudden. It was the result of years of preparation happening quietly in the background. But now the real question begins. Will this strategy help Mercedes gain an advantage in the next phase of the EV race? Or will the rest of the industry soon begin moving toward similar motor technology as well? And perhaps the biggest question of all, which Mercedes model will receive this technology first? Because revolutionary technology rarely appears across an entire lineup immediately, especially at a company like Mercedes. Usually, new innovations are introduced first in premium and high-performance vehicles. That is why attention is now shifting toward future AMG electric models. When people hear the AMG name, they think of more than just luxury. They think about speed, aggressive acceleration, and a thrilling driving experience. And this is exactly where Axial Flux motor technology could make the biggest impact. If a motor can deliver more power while occupying less space and reducing weight, then the advantages become far more noticeable in high-performance vehicles designed for speed, responsiveness, and driving excitement. But this story is not only about speed and performance. Mercedes is also gradually redefining what luxury EVs should feel like. In the early days of electric vehicles, the formula seemed simple. Add a large battery, build the car, and offer long range. But today, premium car makers are focusing on much more than that. Now the attention is shifting toward driving feel, balance, weight distribution, handling, and the overall experience behind the wheel. Mercedes may be trying to show that the future of luxury EVs will not be defined only by larger screens or longer range figures. It will also be shaped by the engineering hidden underneath the car. And this is where Mercedes' performance EV strategy becomes interesting. Tesla built its reputation around software, acceleration, and advanced drivetrain technology. BYD strengthened itself through battery innovation, cost efficiency, and massive manufacturing scale. Mercedes, however, may be aiming to prove that premium engineering and driving dynamics are still some of its greatest strengths. If a car feels lighter, responds faster, and delivers power more smoothly, the entire driving experience can feel completely different. But that does not mean every Mercedes vehicle will suddenly start using this motor technology overnight. New technologies usually enter the market step by step. Companies first introduce them in limited models, then study production feedback, improve the system further, and only after that expand to larger-scale production. Because creating a concept is one thing. Producing millions of reliable vehicles is something entirely different. The real challenge begins when moving from prototype to mass production. A technology may perform perfectly inside a laboratory, but delivering it to thousands or millions of real customers requires solving many other problems. Reliability, heat control, manufacturing processes, supply chains, and production costs all need to work together smoothly. And this is where the big challenges begin. At this point, an important question naturally comes up. If axial flux motor technology is so impressive, if it can deliver more power in less space while improving efficiency and performance, then why hasn't every major automaker already adopted it? After all, companies like Tesla, BYD, Toyota, Hyundai, and many others have been building EVs for years. The answer is simple. A technology looking promising and producing it at large scale are two very different things. The first challenge is production cost. Designing a completely new type of motor is not as easy as changing its shape. It often requires entirely new manufacturing tools, testing systems, assembly lines, and sometimes even a completely redesigned supply chain. And for companies producing millions of cars every year, even a small increase in cost can have a massive financial impact. That is why automakers adopt new technologies very carefully. Then comes the issue of materials. High-performance electric motors often rely on advanced magnetic materials and specialized components that may not always be easily available. If supply becomes unstable or prices rise sharply, the entire production process can face serious problems. So building a powerful motor is not enough. Maintaining a stable supply chain is equally important. Then comes another major challenge: heat management. More power sounds exciting, but higher performance often generates more heat. And if that heat is not controlled properly, performance can drop and long-term reliability can suffer. That is why cooling systems are not just a minor detail in EV engineering. In many cases, they become one of the most important parts of the entire design process. Manufacturing complexity is another big factor. The automotive industry has decades of experience producing traditional electric motors. But introducing a completely new motor architecture is never simple. Production machines may need to change, workers may require new training, and maintaining quality control can become far more difficult. And then comes the biggest challenge of all: scale. A company can build 500 or even 5,000 advanced vehicles and impress the world with innovative technology. But producing millions of units consistently is the real test. That is the moment when it becomes clear whether a technology is truly the future of the industry or simply a premium engineering experiment. Repair and maintenance also become important concerns. New technology often means new components, specialized servicing, and different maintenance requirements. If the system becomes too complicated, ownership costs for customers could increase over time. And finally, there is reliability. A company like Mercedes does not only sell performance, it also sells trust and long-term dependability. If a technology cannot deliver consistent performance over many years, then no matter how advanced it appears, its long-term impact may remain limited. Now, this brings us to another important point: why many people see this as a wake-up call for Tesla and BYD. Whenever a major technological breakthrough happens in the EV industry, its impact rarely stays limited to just one company. It immediately creates pressure across the entire market, especially on the brands already leading the race. And that is exactly what may be happening with YASA's axial flux motor technology. From the outside, this may look like just another technology upgrade from Mercedes, but internally, it could represent a serious signal to competitors like Tesla and BYD. Both companies currently dominate the EV world, but in very different ways. Tesla is known for software innovation, performance, and drivetrain efficiency. BYD, on the other hand, has built its strength through battery technology, aggressive cost control, and massive manufacturing capacity. One company leads through technology and software integration, while the other dominates through scale and affordability. But axial flux motor technology has the potential to shift the direction of this competition entirely. Until now, the EV battle has mostly been about three things: longer range, faster charging, and lower prices. But with flux motor technology entering the discussion, the competition may slowly shift towards something new: motor performance and efficiency. If a company can deliver more power, better efficiency, and smarter use of battery energy with a lighter motor setup, people may start caring about more than just battery size and range numbers. And this is where the challenge for Tesla could become more serious. One of Tesla's biggest strengths has always been its motor and drivetrain performance. But if Mercedes starts offering an equally powerful or even more refined driving experience through technologies like YASA's Flux motor, Tesla's image as the EV technology leader could face stronger competition. This becomes even more important in the premium segment, where customers do not only compare specifications. They care about how the car actually feels to drive. For BYD, the pressure could be slightly different. BYD built its strength through battery production, cost control, and massive manufacturing scale. But if flux motor technology helps cars use battery energy more efficiently, then the importance of simply adding larger batteries could slowly decrease. In other words, the future EV race may not be won only by battery size anymore. Another major shift is that the competition could move from who sells more EVs to who builds the better EV. If Mercedes delivers a smoother, quieter, and more premium driving experience using this technology, many customers may start looking beyond Tesla and BYD, especially in the luxury market. And in the EV world, customer trust matters a lot. One more important thing is that both Tesla and BYD are companies that react quickly when they see a new opportunity. If flux motor technology proves successful, pressure will naturally increase on them to improve their own motor systems or explore completely new approaches. That means the next phase of EV competition may become more about innovation speed than just market share. Now comes another big question. Is this technology the future for everyone, or will it remain limited to expensive luxury cars? Whenever a new automotive technology appears, people ask the same thing. Will regular customers ever get access to it? And the same question is now being asked about YASA's flux motor technology. At first glance, it may seem like this kind of advanced motor will remain limited to premium vehicles. But if we look at automotive history, many technologies followed the same path. Features like airbags, ABS, automatic transmissions, and touchscreens first appeared in luxury cars before eventually becoming common in everyday vehicles. As production increased and costs came down, those technologies slowly reached the mass market. Many experts believe flux motor technology could follow a similar journey. Right now, it will most likely stay limited to premium EVs because manufacturing these motors is not simple. The production process requires high precision and advanced engineering. But if more companies start adopting the technology, manufacturing volume could increase and costs may slowly decrease over time. And if that happens, axial flux motors could eventually appear in mid-range EVs as well. For everyday customers, that could mean getting better efficiency, stronger performance, and a smoother driving experience, features that today are mostly limited to expensive vehicles. But will customers actually be willing to pay extra for it? That depends on the real-world experience. If people can clearly feel that the car performs better, uses battery energy more efficiently, and maintains performance over time, many buyers may accept a slightly higher price, especially if it improves long-term value. Now, when we look at the next 5 to 10 years, technologies like flux motors could change the EV industry in a major way. Cars could become lighter, motor setups could become smaller, vehicle designs could become more flexible, and range could improve without simply increasing battery size. And that may completely change the way future electric cars are designed and experienced. If you enjoy deep and informative stories about EV technology and the future of cars, Don't forget to subscribe to the channel for more videos like this.